All right, hello Facebook. Welcome to EP Lunchtime Chat. This is where we give you a little glimpse into what it's like behind the scenes at the Denver Museum of Nature and Science. The four people you see on your screen are educators and performers at the museum. We are out on the floor presenting content, and then we go back in the back room. We get into some serious conversations, including sometimes talking about some of the most controversial questions in all of science. And that's what we're going to talk about today. Brontosaurus or Brontosaur isn't. One of a question that has polarized the scientific community for over 100 years. But first, let's introduce ourselves. A fun fact I've noticed is people can usually name 5 or fewer dinosaurs or more than 20 dinosaurs. So I'm going to introduce my colleagues, and they're going to tell us how many dinosaurs they think they can name. My name is Mitch. I think I can name like 23 dinosaurs. And then we also have Keelan, who froze temporarily.
Hi, I'm Keelan. I think I can probably name 5 or fewer dinosaurs.
Excellent. And then we have Jim in the Green Lantern shirt.
Hello. Let's see. I think I could probably name about 30 or 40 dinosaurs.
Excellent. And then last but not at all least, we have Vince.
Yeah, I think maybe I can name maybe 50 or more, but the question if I can spell them.
Yes, a totally different question. All right, so we're going to talk about the very controversial Brontosaurus. I have one on my shirt, which is hands down one of the most popular dinosaurs ever discovered, even though for over 100 years, paleontologists agreed that it was not a real thing. There had never been a Brontosaurus. And then recently, it's come back. And let's see, looks like Keelan is frozen. So Jim, do you want to tell us a brief version of the history of the Brontosaurus?
Sure. Yeah, I can do that. Let's see. I guess it all started back about 1877, something like that, when a paleontologist named Marsh started digging up dinosaurs out here in the West, and he found a partial skeleton of something that he named the Parasaurus. A couple of years later, 1879, he found another more complete skeleton that he named Brontosaurus. And things kind of went on for a while there until 1903, another paleontologist named Riggs figured out that they were pretty much, or at least in his opinion, they were pretty much the same thing. But since the earliest one had been named, the earliest discovery had been named Apatosaurus, that's what he said they should all be named now. And 1905, there was a full skeleton up in the, I think it was in the American Museum of Nature and Science, or the Carnegie, or the Yale Peabody Museum, one of the two. And Brontosaurus, it was labeled as Brontosaurus, despite what Riggs had been saying. And so the name really took off. It was a very popular dinosaur until the 1970s, when some folks really took exception to it. And that's when they really kind of officially got rid of the the Brontosaurus name. But then in 2015, a recent study got much more complicated and much more detailed, realized that, yeah, there's enough difference, if you look close enough, that the two species really are separate. They have actually two different genuses of dinosaurs.
Yeah, so the Brontosaurus is back, or is it? One thing that's very weird is everything we use to determine species of living animals is completely irrelevant when we look at dinosaurs. Vince, can you talk to us about why it's hard to speciate dinosaurs?
Well, yeah, because as we find more and more dinosaurs, we have one species, we say that give that name Apatosaurus, okay? And then let's say you find another species, and let's say that it's applicable, Brontosaurus, right? And now we have a missing link between these two species, just as we have today with missing links, right? And if we were to find this missing link dinosaur between Apatosaurus and Brontosaurus, maybe because Apatosaurus is a little bit more robust, a little bit more junk in the trunk, while Brontosaurus, well, a thunderous lizard, amazing name at that, a little bit more slim, generally speaking, for a 30-ton animal. But let's say you find that Patabronti mix, right? Well, then you've created two new missing links in that species discovery. And then, as you said, it's way more complicated for deceased and extinct animals rather than extant or living animals.
Yeah, so when it comes to taxonomy, in a lot of fields, you have lumpers and splitters. You have people who look at things and they're like, they're all generally similar, they're all generally the same thing, or people who look at things and they're like, there's a little bit difference, this is a new species. So, well, in science, there are never any settled questions. So even though many of the pop science headlines proudly proclaim that the Brontosaurus is back, it is actually pretty controversial among paleontologists. And let's go to Keelan. Keelan, what is your opinion? Is the Brontosaurus a valid species or not?
I think that ultimately, as with a lot of things in science, it'll come down to math and very like small specific little specifications type of stuff that'll distinguish one species from another and one genus from another. Personally, like I would really like it if Brontosaurus came back, because when so nostalgically, I would like it to return. But it's fun to watch that kind of that scientific process firsthand as they kind of work around it, trying to figure out where it really fits, where.
Yeah, so the Brontosaurus is a really fascinating one because, so Jim mentioned it was first named by O.C. Marsh during a really awesome period in paleontology known as the Bone Wars, when these two guys, O.C. Marsh and Charles Drinker Cope, were going nuts finding dinosaurs in the US. And they were so dedicated to one-upping each other that they were very, very sloppy. They cataloged hundreds of different dinosaur species, and then when the dust settled like 50 years later, they really had cataloged like 70. There was one species that between the two of them, they cataloged and named 7 different times. What's interesting is that happened over and over and nobody cared, but for some reason, the Brontosaurus really took a pop culture hold. And so it's just a dinosaur that a lot of people hold really close to their hearts. One of the first ever animated movies ever made in the US, 1914, was called Gertie the Dinosaur. Gertie the something. Anyway, and it was a Brontosaurus. And so the Brontosaurus has been like a cultural icon. And so normally science gets to do its thing, and that's fine. But when it steps on people's toes, it's kind of like Pluto. The Brontosaurus is the Pluto of dinosaurs. Vince?
Yeah, I mean, we talked earlier about, just how closely tied the dinosaurs and the American West is. We can look from anything from gas and oil, let's say like Sinclair. What is their mascot other than a Brontosaurus or a Parasaurus right there? We can see, just right here in Colorado, just significant sauropod finds, such as a Dinosaur National Monument. You can see these huge deathbeds of Parasaurs and other sauropod dinosaurs, just conglomerated onto each other. You can go all the way to La Junta and walk on this prehistoric Jurassic beach in the footsteps of large sauropod dinosaurs, and then it's just their family group is just sincerely amazing. But they had a really great imprint on the American West, and we can see that kind of trickle down effect into pop culture with the Land Before Time and Jurassic Park and Walking with Dinosaurs and all that jazz.
Yeah, and this controversy happened again in 2009 when a couple of researchers published a paper saying that the Triceratops was not a valid species and was actually just a juvenile form of the Torosaurus. And in the age of Twitter, this exploded, and the hashtag Tricerafail went totally viral. But ultimately, people pointed out, as Jim mentioned before, whichever one got named first is the name that gets to stick. So even if their research is correct, then Triceratops would be the name that sticks.
That's right. And, I was talking with, I think, Tyler about, their find in, was it Centennial, that Torosaur up there. And I was asking him about, how, well, isn't it, he's saying it was a juvenile Torosaur, so just maybe a young teenager. And it's like, how do you, shouldn't it be like how how do you know it's a, it shouldn't be like an adult Triceratops then, if it's, because that earlier paper was saying that the Torosaur would be the older Triceratops with a bigger frill essentially going upward. But he said that they had new discoveries and new data that suggest that Torosaur is its own species of ceratopsian, which is still pretty interesting how that Triceratops pretty much did have the Apatosaur, Brontosaur, but confined to maybe like 5 or 7 years, and then it's back to like Triceratops and Torosaur again.
Yeah, just don't mess with my Triceratops. That's all I have to say. That was my favorite one.
That's right. Don't mess with Dingar, man.
What kind of age markers can you look for on the bones of a dinosaur to tell if it's a juvenile or if it's an older member of the species, the same species?
Well, there are some scientists have been recently decided to be cutting into dinosaur bone. Back in the days of Cope and Marsh, they would never have wanted to cut into any dinosaur bone because that was on the verge of heresy. But now it's, if you want to do the next step of science, you better cut into those dinosaur bones. And so we can see these growth rings like trees in these dinosaur bones, especially for large sauropod dinosaurs. So for some of these, they were only about, the eggs were only about the size of a cantaloupe, maybe, 9 pounds at birth, and then they had to grow into 30 tons, to survive. So these juvenile sauropods are probably growing so fast, you could probably watch them grow within the day in some of them, because they just grow remarkably fast, and what causes them to grow so fast, they can eat everything and anything, which you see in some Diplodocuses, which the museum has in our prehistoric journey, and in a Parasaurus, that they have 2 types of teeth when they're younger. Meanwhile, when they get older, they switch to the peg teeth that we see in the Diplodocus, with kind of like a rake. They just kind of strip those ferns. Meanwhile, the juveniles and the babies have kind of spoon-like teeth, kind of like Camarasaurus, which is the long neck in the parking garage, sticking his head out there. And those teeth are meant for eating cycads, which is a bit rougher. So the babies have both these teeth, which means it's a buffet. They can eat anything and everything, and then once they get big enough, then they start to get that peg-like teeth again, like the adults, and then they go straight to eating ferns. But at that point, they've achieved, a weight and a height that no carnivore would want to mess with in general.
Here I was.
So is there?
Go ahead, Keely.
So is their teeth related to their body size, basically what they can reach, what they can access, and to make them to eat more availability of stuff so they can grow as fast as possible to achieve that size?
Yeah, so you don't want to limit your you don't want to be a picky eater if you have a lot of bigger carnivores that you're trying to outgrow. But that is a good question. I don't know exactly when they would start to lose their spoon-like teeth and upgrade into pig-like teeth. But you can imagine, probably like a 2-week-old Apatosaurus, after it's hatching, it's going to look like a lanky Great Dane dog, like a calf that was just born. Really long legs, gangly looking guy, and then they're going to start growing like mad. But dinosaur eggs, they have to allow oxygen into that embryo, that baby ate. An egg can only get so big before it starts to become structurally unsound because of all these tiny little holes that allow that oxygen to seep through.
I was just watching some of the Aliens movies, and I was really, I was like, nothing can grow that fast. But I guess I'm wrong. Take that, my understanding of nature. Yeah, and it's really interesting with the big long-necked dinosaurs is, so some of them, like the Brachiosaurus, we all remember in Jurassic Park, that first one when it goes up on its hind legs and eats some trees from the top of a tree and then slams back down and everything shakes. But based on their teeth, a lot of the Apatosauruses that were found in the Morrison Formation, part of which is in Colorado, but they weren't found in Colorado. They found that they actually were not reaching up high. They were mostly eating things on the ground, like Vince was saying, ferns and grasses. And the reason they have those really long necks is because when they're that big, it takes a lot of energy to move at all. So they take like one step and then eat everything they can reach. And then they take another step and eat everything they can reach. And so they just have a massive feeding envelope.
Yeah, and I can't remember which scientist it was, but he compared the long-necked dinosaurs, in particular to our Diplodocus, as the suspension bridge model. So if you look at like the Golden Gate or the Brooklyn Bridge, and you can almost see the outline of a sauropod, with his long tail and long neck outstretching in both directions. And it's a fine model if your dinosaur isn't moving. Bridges don't move. But one thing that does move are these irrigators for farms, those circular irrigators. And they're pretty much designed in the same way that we would expect for our sauropods. They have these stabilizers coming out at the tops of them. Sauropods have a unique vertebrae. Instead of having one, bump, if you feel the middle of your back, you can feel these bumps, your vertebrae. Sauropods, their vertebrae has a bifurcated top, and we actually have a bifurcated vertebrae in these top C-section vertebrae here, because we have a pretty heavy head. Was it 8 pounds, 10 pounds, depending how heavy your brain is. But we constantly move our head around a lot, just as much as these sauropod dinosaurs would, as you, would too. So they have, that bifurcated vertebrae, and so do we. Just like these short little ones to move our head around constantly, because our inner ear, is constantly balancing our head constantly, And those sauropods, they're moving their heads back and forth constantly eating, And so we see these spinal cords for animals that have really heavy heads. Some cows with huge horns have these bifurcated vertebrae that help support their, the weight at the end of their neck.
Awesome.
Well, yeah, but that's the Diplodocus. Did the Brontosaurus and the Parasaurus also rake the ground like that? Or I thought they were more, more tree level feeders, with their necks were up a little higher.
I think I might have been reading about Diplodocus a little bit, yeah, but I don't think the Parasaur and the Brontosaurus would have that much way to look up. We see a lot of in a lot of drawings, this kind of the swan neck for sauropods, and they try to mend the two between the two types of sauropods, the ones that are pretty much just out like a crane, just go straight out, and then like a Brachiosaurus that goes straight up, almost like a giraffe. That's a good question. I'll have to look more into that.
Yeah, I know. I was reading some research, and they were being pretty specific about the Apatosaurus in the Morrison Formation, where they had found this. So at least the article, which I think was a PBS article, wasn't making broad claims besides that. But I know at, I'm going to forget which museum, but the museum that I think has O.C. Marsh's original Brontosaurus skeleton, they actually reposed it a few years ago based on new data, so that it is more horizontal than vertical. So I think that's the way it's trending, but if there's anything we've learned from this conversation, who knows what we'll think once we find a few more fossils and a few more fossil beds. We're running around down to the end of time, so we're gonna do lightning round of unanswered questions of dinosaurs. And we're gonna start with Jim. The Stegosaurus has these beautiful plates, and in Voyage to the Center of the Earth, it was suggested they could flatten them out and glide on them like a flying squirrel, which it definitely didn't work. It's been suggested they're used to regulate body temperature or possibly something else. Jim, what is your wild theory on what Stegosaurus plates are for?
You talking about the big plates on their back? That could be for display purposes, or temperature control or display purposes for mating, attracting a mate.
All right. Now, Keelan, let's talk about where is my list? Okay, let's talk about Tyrannosaurus Rex. Was it covered in feathers, and what color were those feathers?
Sorry, can you throw that?
Yeah, so we know that some ancestors of T-Rex definitely had feathers. There's no direct evidence that T-Rex had feathers yet, but I'm throwing it to you to speculate. What kind of feathers? What color were they?
I personally would love to think that T-Rex looked like a giant chicken, especially if you've ever encountered roosters. They're really aggressive. So I'd really like to think of T-Rex as like just a big, brightly colored, like modeled, like really cool red and black rooster.
I like to think about that too. All right, Vince. What did dinosaurs sound like?
Now that's a fun question. Now some scientists say that Stegosaurus sang beautifully because no one can say otherwise. Meanwhile, Parasaurolophus, which is this hadrosaur with a huge kind of a crest coming off his head, was hollow inside and believed to be able to force air, kind of like a big trombone, into that tube to reverberate. And some have even speculated that this tube would be able to vibrate at infrasound levels, almost like crocodiles when they create that deep sound when they want to mate. And that sound can travel for miles and miles. So they could have been created to use these sounds for mating. They could have used it for attack. They could have. Nowadays we have sound weapons that can create an ungodly amount of decibels and what have you, but this could have been generated biologically, a biological sound weapon, by a parasaur. Could have almost, some has theorized that it could have scrambled a T-Rex's brain with the amount of sound it could have generated. But probably, I would think, if you ever heard like a mad goose, I think that's what maybe a T-Rex might sound like. And they hiss sometimes too. It's scary, like a hissing T-Rex. That'd be interesting.
Awesome. So there you have it, our potential answers to some of the big unanswered questions of paleontology. That's it for our little lunchtime break. Thank you so much for joining us, if you joined us. And for the four of us, let's all do an impression of a dinosaur and freeze to go out. Ready? 3, 2, 1, dinosaur.